Ariane 5 is a European heavy-lift launch vehicle that is part of the Ariane rocket family, an expendable launch system used to deliver payloads into geostationary transfer orbit or low Earth orbit. Ariane 5 rockets are manufactured under the authority of the European Space Agency and the Centre National d'études spatiales. Airbus Defence and Space is the prime contractor for the vehicles, leading a consortium of subcontractors. Ariane 5 is operated and marketed by Aerospace as part of the Ariane program. Ariane builds the rockets in Europe and Aerospace launches them from the Guiana Space Centre in French Guiana. Ariane 5 succeeded Ariane 4, but was not derived from it directly. Ariane 5 has been refined since the first launch in successive versions, G, G+, GS, ECA, and most recently, S. ESA originally designed Ariane 5 to launch the Hermes spaceplane, and thus intended it to be human-rated from the beginning. 2 satellites can be mounted using a SYLDA carrier. 3 main satellites are possible depending on size using SPLTRA. Up to 8 secondary payloads, usually small experiment packages or mini-satellites, can be carried with an ASAP platform. As of July 2015, update, Aerospace has signed contracts for Ariane 5 ECA launches up till 2023, after planned introduction of Ariane 6 in 2020. Vehicle description: cryogenic mainstage Ariane 5's cryogenic H173 mainstage is called the EPC. It consists of a large tank 30.5 meters high with 2 compartments, one for liquid oxygen and one for liquid hydrogen, and a Vulcain 2 engine at the base with a vacuum thrust of 142 tons force. The H173 EPC weighs about 189 tons, including 175 tons of propellant. After the main cryogenic stage runs out of fuel, it can re-enter the atmosphere for an ocean splashdown. Solid boosters attached to the sides are 2 P-241 solid rocket boosters, each weighing about 277 tons full and delivering a thrust of about 722 tons force. They are fueled by a mix of ammonium perchlorate and aluminum fuel and polybutadiene. They each burn for 130 seconds before dropped into the ocean. The SRBs are usually allowed to sink to the bottom of the ocean, but like the Space Shuttle solid rocket boosters, they can be recovered with parachutes, and this has occasionally been done for post-flight analysis. The most recent attempt was for the first Ariane 5 ECA mission. One of the 2 boosters was successfully recovered and returned to the Guiana Space Center for analysis. Prior to that mission, the last such recovery and testing was done in 2003. The French M51 SLBM shares a substantial amount of technology with these boosters. In February 2000, the suspected nose cone of an Ariane 5 booster washed ashore on the South Texas coast, and was recovered by beachcombers before the government could get to it. Second stage: the second stage is on top of the main stage and below the payload. The Ariane 5G used the EPS, which is fueled by monomethylhydrazine and nitrogen tetroxide. It also has 10 tons of storable propellants. The EPS was improved for use on the Ariane 5G+, GS, and S. Ariane 5 ECA uses the ESC, which is fueled by liquid hydrogen and liquid oxygen. The EPS upper stage is capable of multiple ignitions, first demonstrated during Flight V26, which was launched on 5 October 2007. This was purely to test the engine, and occurred after the payloads had been deployed. The first operational use of restart capability as part of a mission came on 9 March 2008. When 2 burns were made to deploy the first automated transfer vehicle into a circular parking orbit, followed by a 3rd burn after ATV deployment to deorbit the stage. This procedure was repeated for all subsequent ATV flights. fairing. The payload and all upper stages are covered at launch by a fairing, which is jettisoned once sufficient altitude has been reached. The fairing is also used for aerodynamic stability and protection from re-entry heating. Variants, launch pricing and market competition. As of November 2014, update. The Ariane 5 commercial launch price for launching a mid-sized satellite in the lower position is approximately $60 million, competing for commercial launches in an increasingly competitive market, mainly due to SpaceX. The heavier satellite launched in the upper position on a typical dual satellite Ariane 5 launch is priced higher. Total launch price is on the order of €150 million. Future developments. Ariane 5Me. The Ariane 5Me was in development until 2015 and seen as a stopgap between Ariane 5 ECA, Ariane 5S and the new Ariane 6. With first flight planned for 2018, it would have become ESA's principal launcher until the arrival of the new Ariane 6 version. The Ariane 5Me uses a new upper stage, with increased propellant volume, powered by the new Vinci engine. Unlike the HM7B engine, it can restart several times, allowing for complex orbital maneuvers such as insertion of two satellites into different orbits, direct insertion into geosynchronous orbit, planetary exploration missions, and guaranteed upper stage deorbiting or insertion into graveyard orbit. The new launcher also includes a lengthened fairing up to 20 meters and a new dual launch system to accommodate larger satellites. Compared to an Ariane 5 ECA model, the payload's GTO increases by 15% to 11.5 tons and the cost per kilogram of each launch is projected to decline by 20%. Development. Originally known as the Ariane 5 ECB, Ariane 5Me was to have its first flight in 2006. However, the failure of the first ECA flight in 2002, combined with the deteriorating satellite industry, caused ESA to cancel development in 2003. Development of the Vinci engine continued, though at a lower pace. The ESA Council of Ministers agreed to fund development of the new upper stage in November 2008. In 2009, EADS Astrium was awarded a €200 million contract, and on April 10, 2012 received another €112 million contract to continue development of the Ariane 5Me, with total development effort expected to cost €1 billion. On the 21st of November 2012, ESA agreed to continue with the Ariane 5Me to meet the challenge of lower-price competitors. It was agreed the Vinci upper stage would also be used as the second stage of a new Ariane 6, and further commonality would be sought. Ariane 5Me qualification flight is scheduled for mid-2018, followed by gradual introduction into service. On the 2nd of December 2014, ESA decided to stop funding the development of Ariane 5Me and instead focus on Ariane 6, which should have a lower cost per launch and allow more flexibility in the payloads. Solid propellant stage work on the Ariane 5 EAP motors have been continued in the Vega program. The Vega first stage engine, the P-80 engine, is a shorter derivation of the EAP. The P-80 booster casing is made of filament wound graphite epoxy, much lighter than the current stainless steel casing. A new composite steerable nozzle has been developed, while new thermal insulation material and a narrower throat improve the expansion ratio and, subsequently, the overall performance. Additionally, the nozzle now has electromechanical actuators which have replaced the heavier hydraulic ones used for thrust vector control. These developments will probably later make their way back into the Ariane program. The incorporation of the ESCB with the improvements to the solid motor casing and an uprated Vulcain engine would deliver 27,000 kilograms to LEO. This would be developed for any lunar missions, but the performance of such a design may not be possible if the higher max Q for the launch of this rocket poses a constraint on the mass delivered to orbit. Ariane 6. The finalized design of the next-generation rocket Ariane 6 calls for a smaller rocket capable of launching a single satellite of up to 6.5 tons to GTO. The current design features 3 identical solid motors as a first stage, a single similar solid motor as a second stage, and a liquid hydrogen-fueled cryogenic third stage powered by the same Vinci engine currently under development for the Ariane 5 Me. While ESA governments are scheduled to decide in December 2014 whether to proceed with full development, the chairman of the German Aerospace Center criticized the current form of the Ariane 6, and the satellite operators are concerned that the rocket will not be fully competitive. Development is projected to cost €4 billion. Its first test launch is set for 2021. Ariane 6 is planned to be launched for about €70 million per flight, or about half of the Ariane 5 rocket's current price. Notable launches: Ariane 5's first test flight on 4 June 1996 failed, with the rocket self-destructing 37 seconds after launch because of a malfunction in the control software. A data conversion from 64-bit floating point value to 16-bit signed integer value to be stored in a variable representing horizontal bias caused a processor trap because the floating point value was too large to be represented by a 16-bit signed integer. The software was originally written for the Ariane 4, where efficiency considerations led to 4 variables being protected with a handler, while 3 others, including the horizontal bias variable, were left unprotected because it was thought that they were physically limited or that there was a large margin of error. The software, written in Ada, was included in the Ariane 5 through the reuse of an entire Ariane 4 subsystem, despite the fact that the particular software containing the bug, which was just a part of the subsystem, was not required by the Ariane 5 because it has a different preparation sequence than the Ariane 4. The second test flight was a partial failure. The volcano nozzle caused a roll problem, leading to premature shutdown of the core stage. The upper stage operated successfully, but it could not reach the intended orbit. A subsequent test flight proved successful, and the first commercial launch occurred on 10 December 1999 with the launch of the XMM Newton X-ray Observatory satellite. Another partial failure occurred on 12 July 2001, with the delivery of 2 satellites into an incorrect orbit. At only half the height of the intended GTO, the ESA Artemis telecommunications satellite was able to reach its intended orbit on 31 January 2003, through the use of its experimental ion propulsion system. The next launch did not occur until 1 March 2002, when the Invisit environmental satellite successfully reached an orbit 800 kilometers above the Earth in the 11th launch. At 8,111 kilograms, it was the heaviest single payload until the launch of the first ATV on March 9, 2008. The first launch of the ECA variant on the 11th of December 2002 ended in failure when a main booster problem caused the rocket to veer off course, forcing its self-destruction 3 minutes into the flight. Its payload of 2 communications satellites, valued at about €630 million, was lost in the ocean. The fault was determined to have been caused by a leak in coolant pipes, allowing the nozzle to overheat. After this failure, Aerospace delayed the expected January 2003 launch for the Rosetta mission to 26 February 2004. But this was again delayed to early March 2004 due to a minor fault in the foam that protects the cryogenic tanks on the Ariane 5. As of April 2014, the failure of the first ECA launch was the last failure of an Ariane 5. Since then, all subsequent launches have been successful, with 69 consecutive successes that stretch back to 9 April 2003, with the launch of INSAT-3A and Galaxy 12 satellites. On the 27th of September 2003, the last Ariane 5G boosted 3 satellites, in Flight 162. On the 18th of July 2004, an Ariane 5G Plus boosted what was at the time the heaviest telecommunications satellite ever, Anik F2, weighing almost 6,000 kg. The first successful launch of the Ariane 5 ECA took place on 12 February 2005. The payload consisted of the XTAREUR military communications satellite, a SLOSHSAT small scientific satellite, and a MaxSat B2 payload simulator. The launch had been originally scheduled for October 2004, but additional testing and the military requiring a launch at that time delayed the attempt. On the 11th of August 2005, the first Ariane 5GS boosted THAICOM-4 IPSTAR-1, the heaviest telecommunications satellite to date at 6,505 kg, into orbit. On the 16th of November 2005, the third Ariane 5 ECA launch took place. It carried a dual payload consisting of Spaceway F2 for DirecTV and Telkom 2 for PT Telekomunikasi of Indonesia. This was the rocket's heaviest dual payload to date, at more than 8,000 kg. On the 27th of May 2006, an Ariane 5 ECA rocket set a new commercial payload lifting record of 8.2 tons. The dual payload consisted of the Thaicom 5 and SatMex 6 satellites. On 4 May 2007, the Ariane 5 ECA set another new commercial record, lifting into transfer orbit the Astra 1L and Galaxy 17 communication satellites with a combined weight of 8.6 tons, and a total payload weight of 9.4 tons. This record was again broken by another Ariane 5 ECA, launching the Skynet 5B and Star 1C1 satellites, on the 11th of November 2007. The total payload weight for this launch was 9,535 kg. On the 9th of March 2008, the first Ariane 5 SATV was launched to deliver the first ATV called Jules Verne to the International Space Station. The ATV was the heaviest payload ever launched by a European rocket, providing supplies to the space station with necessary propellant, water, air and dry cargo. This was the first operational Ariane mission which involved an engine restart in the upper stage. On 1 July 2009, an Ariane 5 ECA launched TERESTAR-1, the largest commercial telecommunications satellite ever built. On 28 October 2010, an Ariane 5 ECA launched Eutelsat's W3B and Broadcasting Satellite System Corporation (SBSAT-3B) satellites into orbit. However, the W3B satellite failed to operate shortly after the successful launch and was written off as a total loss due to an oxidizer leak in the satellite's main propulsion system. The BSAT-3B satellite, however, is operating normally. On the 22nd of April 2011, the Ariane 5 ECA flight VA201 broke a commercial record, lifting Yarsat-1A and Intelsat New Dawn with a total payload weight of 10,064 kg to transfer orbit. This record was later broken again during the launch of Ariane 5 ECA flight VA208 on 2 August 2012, lifting a total of 10,182 kg into the planned geosynchronous transfer orbit, which was broken again 6 months later on flight VA212 with 10,317 kg sent towards geosynchronous transfer orbit. Launch history. Scheduled flights, time zone in Kourou.